DC generator. Perform no-load and load test and determine characteristics of series and shunt generators. Hello and welcome to this session. We will be conducting no-load and load test on generators. We will also determine the characteristics of series and shunt generators. Let us now learn about conducting load and no-load test of a DC series generator. Performing load and no-load test of a DC shunt generator. So, let us begin.
Let us begin with the first task. We are going to test the DC series generator with no load. Task 1. In this task, we will conduct no load test on a DC series generator. At the beginning, we should note the nameplate details of the DC generator and determine its terminals. Then connect all the components according to the circuit diagram. Figure shows the DC series generator coupled with the armature of the motor. Determine the terminals indicating A and F of the DC series generator using multimeter. Connect the armature terminal A to the input terminal F of the field winding. The output terminal FF of the field winding should be connected to switch. Ammeter and rheostat are in series connected to switch. A voltmeter is connected parallel to the load to measure the induced voltage. Terminal AA of the generator is connected to the voltmeter negative. Now, we should switch on the generator. Measure the generator speed using a revolution counter and note the readings in the table. Measure the induced voltage using voltmeter. Step by step, we need to turn on the field circuit. We need to slowly raise the field current by 0.1 ampere while lowering the field rheostat's resistance and note the readings into the observation table in steps. At last, we should turn off the DC generator and the prime mover. Observation table. We have noted the readings for field current, induced voltage and speed in the observation table. Graph. As per the observation table, you shall be able to draw the graph indicating induced voltage on the y-axis and the field current on the x-axis. Conclusion. We conclude that induced EMF is present even with zero load current on the x-axis curve. Task 2. In this task, we will conduct load test on DC series generator. Let us observe the circuit diagram and start to connect the apparatus. Figure shows the DC series generator coupled with the armature of the motor. Connect the armature terminal A to the input terminal FF of the field winding and AA to the negative terminal of voltmeter. The output terminal F of the field winding is connected to the voltmeter and main switch. Main switch output terminal is connected to the load in series with an ammeter. The output of the ammeter is connected in series with the load lamps. After making all the connections, we should turn on the main switch and then turn on the load. we should note down the readings displayed on the ammeter and the voltmeter. At last, we should turn off the DC generator and the prime mover. Observation table. We have noted the values displayed on the ammeter and voltmeter in the given observation table. Graph. As per the observation table, you shall be able to draw the graph indicating terminal voltage on the y-axis and load current on the x-axis. Conclusion. We conclude that the load test is conducted to draw terminal voltage on y-axis as per the load current on x-axis. Task 3. In this task, we will conduct no load test of a shunt generator. At first, we should note the nameplate details of the DC generator. Let us observe the circuit diagram and start the connection of the apparatus. Figure shows the DC shunt generator coupled with the armature of the motor. Connect the armature terminal A1 to the knife switch. Then connect E2 to the ammeter. Connect the ammeter in series with the rheostat. Connect the voltmeter parallel to the shunt generator. Next, we should turn on the field circuit. We need to slowly raise the field current by 0.1 ampere while lowering the field rheostat's resistance. Here, we need to adjust the speed of the prime mover equal to the generator speed to induce voltage parallel with the armature. At last, we should turn off the DC generator and the prime mover. Observation table. We have noted the field current and the induced voltage parallel to the armature in the table. Graph. As per the observation table, you shall be able to draw the graph indicating induced voltage on the y-axis and the field current on the x-axis. Conclusion. Thus, we conclude that there will be some initial EMF due to the residual magnetism when the field current is 0. Task 4. In this task, we will conduct load test on a DC shunt generator. We can observe from the circuit diagram that lamp load is present on the DC shunt generator. For this experiment, we require two ammeters. One to measure the armature current and the other to measure the load of the current. Connect the armature terminal A2 to the E2 terminal of the shunt winding. Connect the ammeter in series with the rheostat and generator. Connect the voltmeter parallel to the main switch S1 and S2. Connect the A1 terminal of the generator to the voltmeter. Connect the A2 terminal to the negative electrode of the voltmeter. Fuse output is connected to 0 to 15 ammeter in series with load. While keeping the resistance of the field regulator in the cut-in position, we need to maintain the load switch to be open and all circuit switches connected to the light load be switched off. Next, we should turn on the field circuit. Next, we need to adjust the field rheostat and raise the generator's voltage to its rated value to achieve the open circuit voltage value. While loading the DC shunt generator, we should turn on the load switch and switch on a few lamps. At last, we should turn off the DC generator and the prime mover. Observation table. We have recorded the terminal voltage, shunt field current and load current in the observation table. Graph. At last, we need to plot the graph according to the noted readings. Conclusion. Thus we conclude that armature resistance drop as increase in load current denoted by B, so field current, and generator EMF decrease denoted by A.